Good afternoon, everybody. Welcome to a cloudy afternoon of Chem 170 with your host, me, Dr. White. And I hope you're all having a great day. I am. All right, a couple important things. One, after today's lab, I will send out the password for test number 1. You will have until tomorrow, 10 a.m. to upload your answers to test number 1. If you don't have a printer, relax. This one I got last December because my old HP4 finally died after about 25 years of good service. But anyways, if you need a printer, let me know. Those are about $200. It's an HP and it's really good. It's just black and white. But anyways, if you don't have a printer, on a piece of paper, don't try and crowd all the tests into one page, but on paper, write the problem number and then your answer. You do not have to write out any of the question really, just your answers. Make sure all of you upload it as a single PDF file, just like you've been doing the labs. And I promise, by Sunday, 1 p.m., probably a lot sooner, but it's usually the deadline I give myself because things might come up in the next thing I teach tomorrow at the other school, that by 1 p.m. Sunday, if not earlier, I will have the test scores for test number 1, your test scores in D2L. I will also put an announcement and send out an email. They're available. Also by Sunday, 1 p.m., give or take a few minutes or earlier, I will also individually send out to each one of you an email with your points for each answer you put. So if question 1 has A, B, and C, you'll see how many points you got for A, B, and C, and so on for the whole test. Luckily, Dr. White's been for many, many years a computer power user. I know Microsoft products quite well. I know how to do mail merge and all the other nice things you can do. It makes my life easier, and that way you can get the test back, because I'm not going to hand you back in face-to-face. I give it to you and you look at the paper, see what's wrong. All right. Also, next Monday in lecture, I will go through all of test number 1 with the correct answers. That way you can learn which ones, why did I get points taken off? And when I do that, I will cut the part out of the videotape, out of the video, it's not a tape anymore, out of the video that has the test answers, because I don't want them floating around the internet for the rest of the time. And that's that. Any questions about test 1? Oh, one other thing. Between now and tomorrow morning, every couple hours, I will check my email. Tonight, I have my office hours from 5 to 6:15. If you have any questions whatsoever on test while you're taking test number 1, email me or come to my office hour, because remember, there's no such thing as a dumb question in my world. And therefore, while you're taking a test, you can have a question. Will I give you the answer to the question? No, but I'll try and help explain and help you with whatever you're questioning. All right, any questions about test number 1? Well, in that case, let's get back to ethers. Now, an ether, oops, let me turn on my tablet. Hold on one sec. Everybody hear that? All right, now, oxygen with 2 R groups. Remember, R means carbon hydrogens, and R prime is just like X and Y in math. R and R prime mean they can be the same or different. That's an ether. And one of the things I was telling you on Monday was ethers are extremely flammable. Low molecular weights, ethers are flammable. They make gasoline look non-flammable. That's how flammable ethers are. And the most common, widely used, and well-known ether is this one. And the common name is diethyl ether. Remember, common name. Oh, let me write this first. Diethyl ether. And this is really flammable. This has a very low boiling point. The heat from your hands, your body, will cause this liquid to boil. Now, before I go on, I just remembered one other thing I should mention. On Monday, besides going through test number 1, I will go through the alcohol problem set. On Monday, I'll go through the alcohol problem set. So I highly recommend that all of you do that before I do. All right, so diethyl ether is an ether and it's extremely flammable. And the reason I'm bringing that up, but give me a second while I open something else up. All right. Diethyl ether was, I think, the first inhalation anesthetic. What does that mean? Well, you inhale it and it'll knock you out. And that was, I think, discovered about 1850. And unfortunately, it was widely used in American Civil War and afterward. There was one problem using that as an inhalation anesthetic, and that is it's flammable, much worse than gasoline. So you put a patient out and there'd be fumes in his lungs coming out of his mouth. And if there was any kind of spark, or in the old days when they had a candle or other type of flame lamp for light, you'd have a fire, which meant you had a dead patient. And later on in the early 20th century, 1900s, if you cauterize a blood vessel and there were those fumes around, well, you had a fire. You probably had a dead patient now. And you also had a surgeon whose hands were burned, or could be worse, who no longer could operate. Well, it turned out they found that when you replace some of the hydrogens on ethers, like diethyl ether, with halogens, fluorine, chlorine, or bromine, or iodine, it still puts people out as an inhalation anesthetic, but it isn't flammable. Now, when I moved into this house long ago, I've been here, wow, since 98. That's a while ago. I did some stupid things. And the stupid things is I was lifting big, heavy boxes. One, I didn't have a belt on. And two, they were pretty big and heavy. And lo and behold, guess what? I popped my hernia. I had to have a hernia operation. Luckily, friends of my sister and brother-in-law knew an outstanding surgeon who they'd used, in this case, the friend of my brother-in-law's, for heart surgery, and did a good job. And so I went to him and, yeah, you need a hernia operation, actually a double hernia, and I think it's going to be a major repair job. And turned out it was. Now, for those of you, hopefully you've never had to, but if you've ever had to go into hospital for operation, they tell you to get there at a certain time. They put you in a room, tell you to change into the operating gown, make you lay down on a gurney, and they wheel you to the operating room. Well, it just so happens my operation was at a good hospital in Evanston. That's when I lived in Chicago. And the surgeon, no, actually I was here. The surgeon, in Chicago, I was here. The surgeon, he was scheduled for 1 o'clock. So about I got there early and was ready, and they wheeled me to the operating room. And by outside, they didn't wheel me in yet. I could see a big clock on the wall, and it's 10 to 1, 1 o'clock, 5 after 1. And I'm looking, 10 after 1. No, I'm still laying there outside the operating room. And luckily, my anesthesiologist, who I didn't know, but this is one the surgeon I have used, came over and saw I was sort of looking at the clock, what's going on here? And said, relax. You don't know, but your surgeon has one major problem. I said, what? He's never on time, never. So he told me, I'm your anesthesiologist. He asked, what did I do? And I said, well, I'm a synthetic organic chemist. And he said, oh, and he brought over the bottle. This is the inhalation anesthetic, 1 to 2, and I'll also do an intravenous that I'll give you. And the one he showed me was this product. It's called isoflurane. That's just a trade name, I think. And if you see the molecule now on your screen, each bend in a line is a carbon. So it's a carbon here with 2 fluorines and a hydrogen, oxygen, 2 carbons here on this end carbon, 3 fluorines, and on this carbon bond to the oxygen, a chlorine, and a hydrogen. How they came up with that is a good one. I have no idea, because that's not an area of research I've ever worked in. But he was telling me, well, this is it. And I looked at the label and I started explaining, that's an oxygen with this and this, because it also had the IUPAC name on the label, interesting enough. And as I was just talking to him about it and everything, he said, oh, I got to get to work. Sorry, I got to leave. I said, what's up? He said, can't you tell? Your surgeon's here. And they all had their gowns, masks on. I couldn't tell. But anyways, it was major surgery. The surgeon worked on me for almost 5 hours to repair both my hernias. And he said afterward, I made it strong. I don't think the rest of your life you're ever going to have to worry about it, as long as you don't do something stupid and pick up, like I did, 100 pounds of books, 2 big boxes. And in case you're wondering about that surgery, I survived. But anyways, true story. And that's one of the major uses. Another is a solvent of ethers. Now, how do you make ethers? The main way of making ethers is called the Williamson ether synthesis. And by the way, I should be subtle. And you should know this. Aren't you glad I can be subtle? And this is called an alkoxide, which I'll never ask on a test, but I'll use the terminology. Actually, a sodium alkoxide, and it's a R group on an oxygen with negative charge and a sodium cation. Then you react it with an alkyl halide, and here X can be chlorine, bromine, or iodine. And what you get is an ether, plus you make, excuse me, a salt, sodium halide. Now, the ether, the alkoxide, attacks. Did I tell you organic chemists are violent? Instead of saying bonds to, we say attacks the carbon with the halogen, and that's this bond is formed to that same carbon. Again, the Williamson ether, alkoxide plus an alkyl halide is an ether, plus you get salt, sodium chloride. By the way, I don't know if I told you this, but I think you're all familiar with sodium chloride. This is sodium halide. And sodium chloride is table salt. And if you ever go out to lunch, breakfast, or dinner with a bunch of chemists, and unfortunately, I've been guilty of this many times, and somebody wants the salt, like for their French fries, they'll say, can you please pass the knuckle? That's an in-joke. You don't have to laugh. None of you did. All right, let's take a look at how you do this. And the question is 3 points each. Give the organic product or products for the following. And if we look at this, what do we have that's different? Ooh, an oxygen with a negative charge, carbons on it, and a sodium cation, alkoxide. By the way, these can be made easily from alcohols. I'll show you this in a lab. I don't put it in this class as a reaction on a test. Then here I have carbon, ooh, halogen. Remember, when you look at an organic molecule, you should look for what's different. What's not a carbon-carbon single bond or carbon-hydrogen atom. And a halogen counts as that, and that's different. These carbons, I call that R prime. And remember, X can be chlorine, bromine, or iodine. And what you get is an ether. Plus, you don't have to put it down, but I will for today. And you get salt. And remember, the bond from the oxygen anion to the carbon with the R prime is the carbon that the halogen is on. So what this does is it attacks that carbon and kicks this out. That's a sort of pseudo mechanism. This is my R group. This is my R prime. And therefore, R, CH3, oxygen. What carbon has the halogen, the end one of 3? And do you break carbon-carbon single bonds? No. So all these come along, 3 carbons come along. And I've made methyl and propyl ether. And that's the best way. There's another way of making ethers, but this is the best way. And that's how you make an ether.
Dr. White, I have a quick question.
I do say so too. Go for it.
Yeah. What's the little symbol that you drew above the oxygen and the reactant side?
Oh, okay. Let me magnify it through the miracle of technology.
Oh, it's just a minus sign.
When you have are you familiar with an anion and cations?
Yes.
Anion is something with a negative charge, cation. That's a good question. Thank you for asking.
Yeah, thank you.
No, thank you. Your turn to say it back. What cartoon did that come from? Anyways, and we'll be doing cations and anions. And we show an anion with a minus, and I have a, I don't know if I call it a bad habit, but I always put a circle around the negative charges and positive charges I don't. And if you look in certain books, both of them are circled, sometimes neither are. But that's my, I guess you call it idiosyncrasy. So this is an anion, and here we have the sodium cation. And that's what we have, okay? And it's a good question, now you know. And let me rewrite this over again. So, and as I practice what I say I do, there's no such thing as a dumb question. That was a great question. Thank you. And your turn, what would be the organic product or products for the following reaction? Remember, these are the building blocks that organic chemists use to make molecules you use in your daily life. As I look at attendance, we've got a full house today. Standing room only. Actually, in this case, sitting room only. And when you're done, give me a thumbs up. All right, time for Dr. White to get to work. So I will. All right, if we look at this, what's different? Carbon, carbon, oxygen minus, sodium plus, and alkoxide. Here is my R group. Over here, carbon, carbon, carbon with a halogen. This is an alkyl halide, and X can be chlorine, bromine, or iodine. And what do you get? You get an ether plus a salt, but, oops, I'm getting ahead of myself, but you don't have to put that down because I'm only asking, give the organic product or products, and sodium halide is inorganic. So this is my R prime. Remember, the carbon with the halogen is the carbon this oxygen is bonded to. So this is going to attack that carbon. Do we break carbon-carbon single bonds? No. My R group, 2 carbons, ethyl. My R prime, isopropyl. It's important that that's bonded to the center carbon, not the end carbon. And that's how you do it. Now, let me show you something that students sometimes do with this reaction, and it's wrong. For the same reaction, I'll do something like this. And what I see is this oxygen is bonded to the N carbon. Also, you see something else quite wrong on this carbon. How many bonds to it? 5. That will never happen because there's only 4 bonds to carbon. There's only 4 bonds to carbon. And if we look at this carbon, there are 3 bonds. And the student will say, well, I meant, doesn't that mean this is bonded to that? I said, no, it's bonded to this carbon because that's what that structure shows. So it's very important to look at how you are drawing these. This is correct. This is wrong. So don't do that. Oh, let's do another one. These are fun. And have some fun. You're doing high-level organic chemistry. Hopefully you're not in any pain. Actually, you should be proud of yourself. You're doing some sophisticated organic chemistry. And if you finish early, I ask everybody to be patient. Ooh, here's something I haven't used in a while. And I think everybody's done. So let me get to work and do my job. All right, question is, what's the organic product or products that are following? If we look at here, ooh, carbon, ooh, oxygen minus, sodium plus, alkoxide. And I look here, a ring, carbon, carbon, ooh, carbon with a halogen, alkyl halide. Williamson ether synthesis. Remember, X can be chlorine, bromine, or iodine. And this attacks the carbon with the halogen to form an oxygen carbon bond. And you don't have to put it there, but I will. And you also make salt. And what's our methyl? What's our prime? The cyclopentane ring. So I have my methyl group, oxygen, and my cyclopentane. And that's the ether you just formed. Now, the fun part of organic chemistry is not, if I take this and this, what do I get? It's important to know it's, I want to make this compound. What do I start with? And we call that synthesis, and that's the fun part. But now I'm being quite selfish or egotist, not egotist, self-centered, because I'm a synthetic organic chemist, which is what I was trained in and what I really love to do. So let's try one. And on test 2, I'll have 3 or 4 synthesis problems. And what 2 things do react to make that molecule? Oh, I forgot to put something else you'll need here. And that's sodium chloride, NaCl. So what 2 things do you need to make this compound? And you also make this too. Your turn. And if you're done early, please be patient. I try and give everybody time to finish. And I might forget, but don't forget to hand in the lab sometime today, upload it. That's due today. All right, I think everybody's done, so I better get to work. Well, how do you do a synthesis problem? Well, you look at the product, say what's different. Carbons, ooh, an oxygen, more carbons. And they're the same, but I'll still call them. And I'm also getting an alkyl halide. And X can be, in this case, it is chlorine. It could be bromine or iodine. And how do you make, what is this called? It's an ether. And how do you make an ether? Williamson ether synthesis, alkoxide plus an alkyl halide. And now, what's our ethyl? What's our prime? Ethyl. What's the halogen? Chlorine. So my alkoxide, oops, hold on. Excuse me. my alkoxide is this. R prime is ethyl. And my halogen is chlorine. If you react this and this, I will make that compound. Oh, let's do one more. These are super fun. And if you react two things together, and that's my gift to you. When I took organic chemistry, our instructor didn't put the question marks like I do, but that will help you out. If you react two things together, what two things do you have to react to make this plus this? Your turn. And now you're doing the fun part of organic chemistry, synthesis. I turn off my microphone while all right, microphone's back on, blew my nose. Hopefully it won't be running, so I have to go catch it. That's an old joke. All right, let's do this. I think everybody's done. Now, if I look at the molecule you're trying to make, I say, what's different? Ooh, an oxygen. Oxygen there, carbons here and here. This is an ether. Plus, I'm making a salt. Remember, X can be chlorine, bromine, or iodine. And how do you make an ether? You react an alkyl halide plus an alkoxide plus an alkyl halide. Well, I'm going to make this R and this R prime. And if I do that, R is methyl, oxygen minus, sodium plus. That's called methoxide. And by the way, IUPAC has nomenclature for alkoxides, which I know, but I'm not going to teach you. And then R prime is ethyl, and the N carbon is attached to halogen, which is iodine. But wait, what if I call this methyl group R prime and this ethyl group R? In that case, R would be this alkoxide. And R prime would be this alkyl halide, methyl iodide. And that would be a possibility. And the question is, which is correct? This or this? And the answer is they both are. Now, unless you've worked in industry like I have, and most of the faculty at ECC have not, I know one chemist who would know this, but the rest wouldn't. There's a difference between these two, and the difference is how much it costs. That's called cost accounting. And I know from experience, this would be less cost and therefore you didn't maximize your profits. But if you're not considering cost accounting, then either one is acceptable on a test. And that's part of the fun of synthesis, especially at my level. There's always a lot of times more than one way to put chemicals together to make a product. But the only differential is if you're in industry going to sell it, you want the lowest cost, and it's called raw materials, the starting materials. Now, one of the big, how should I say this, regrets when I was a grad student or even undergrad that I had was I didn't take accounting. What do you mean account? Oh, something just fell off my shelf here. Sorry about that. But I didn't take accounting. And I thought later on years, when I was a senior manager first time at one chemical company, I went to the weekly senior manager meeting with the CEO, CFO, and a lot of high-level people in there. And I was the laboratory manager, and that's why I was there. And all of a sudden, they were using terms I had no idea what they're talking about. Like, do you know what gross margin is? Do you know what EBITDA is? And other things like that. And afterward, I went up to the CFO, chief financial officer. I said, where do I learn about these terms? Because they're accounting stuff. He said, yeah. He said, go and buy this book and start reading it. You'll learn. And I did. And that's when I learned accounting terms, that when I went into the meeting, I could do that. The other thing for that company, and actually before that, I learned was called cost accounting. How do you figure out, based on the raw materials, the starting materials, what something will cost per pound? And that's an important thing chemists have to do at my level, and I've done it. And like I said, my regret was I didn't take accounting in undergrad or grad school. But once I got into senior management, part of being a PhD is you learn how to teach yourself stuff you don't know. I did. That's not what I want. That's what I want. So that's the Williamson ether synthesis. And guess what time it is? It's new functional group time. And this new functional group is called epoxides. Now, epoxides, or an epoxide, is a carbon, two of them in a ring with an oxygen. And there can be things on both carbons. And this is called an epoxide. And good news, I have many years experience with epoxides. And one of my patents, I use epoxides. And how many of you ever heard of epoxy coatings? They use epoxides to make the coating. Now, for this class, I'm going to limit myself to one. I don't have a slide, so I better go to my whiteboard. I'm going to limit and talk about just one special epoxide. I could probably do a 8-week lectures on epoxide chemistry alone, but no, we're not going to do that long. And this has got a common name, not the IUPAC. Nobody calls this by the IUPAC. Ethylene oxide. And on a test, I'll never ask you what's the name of that, but I will talk about it. And ethylene oxide is widely used in the United States. And I work for 2 companies that use that, and I did research with that. Now, ethylene oxide is a very dangerous chemical. If under the right conditions you get oxygen, meaning air in there, it blows up quite quickly and badly. I don't know, is there any good blow up? I don't know. But anyways, at one company I worked at, The research center was right next to the production facility. This was in Gurnee, Illinois, about 4 or 5 miles, maybe 3 or 4 miles northeast of Great America. I don't know if you're familiar with the Great America amusement park. And one Friday afternoon, when a bunch of us were sitting around shooting the breeze until we could go home, on Friday, sometimes you did that about a half hour before we were going home on a Friday, we'd sit around and talk, and someone brought up the interesting discussion point was in our plant right next door, a couple hundred yards away from us, they had about 1 million pounds of ethylene oxide stored for use. And the question one person brought up was, if it blew up, would we take out Great America or not? Because we knew if it blew up, we'd be dead immediately. There wouldn't be any question about that. And the consensus was the shock wave would probably hurt some people, but not kill anybody. One other thing, Dr. White's going to try and be good chemist and not use slang. If you work with ethylene oxide like I have, you just call it EO, but I won't. Now, it turns out there's a concept in organic chemistry and nature really called steric strain. When things are really stretched, oh, you have to stretch it real close to get it to connect. It doesn't want to do that. It wants to pop open. A 3-membered ring with an oxygen, 2 carbons wants to pop open. Doesn't want. There's a lot of strain pushing them together. Oh, you really got to put a lot of energy into it. So to get rid of it, you can. It's easy. Well, that's the case with ethylene oxide. Now, the following reaction, do not write down. This ring is so strained that these bonds, either this one or this one, you can break. If you add water, the H goes to the oxygen and the OH goes to the carbon. And you form this diol, which I talked to you about, which you don't have to know, ethylene glycol. And what this really means is when you're doing reactions with ethylene oxide, you want to keep water as far away and out of that reaction vessel because you're going to make this, which you don't want. There are cheaper ways of making ethylene oxide. So when you do a reaction with ethylene oxide, you want to keep the water off. Well, what's a good reaction to do? Well, reacting ethylene oxide with an alcohol. You take an alcohol, react it with ethylene oxide. This will work with any epoxide, but we'll stick this semester to ethylene oxide. You form this new molecule. Notice there's not one, but 2 functional groups. Here I have an ether, and here I have an alcohol. So you make this new molecule that has both an ether and an alcohol in it. And it turns out those ether alcohols, depending on what size R is, are quite useful and used in our daily life, in your daily life. So let's get to work. And the question is, what's the organic product or products for the following? And if we look at this, what do we have that's different here? An alcohol. What do we have here? Oh, ethylene oxide. See, I was good. I didn't use slang. I'll try not to. And what happens when you react an alcohol with ethylene oxide? You get an ether alcohol. And if we look here, what's our methyl? So here I have methyl, my R group, then oxygen. The carbon with the hydroxyl group is the carbon this oxygen is bonded to, then CH2, CH2, OH. And that's how you do it. And I've worked at companies that have done this reaction. One was in Gurnee, and we used to react alcohols, not this one, but other ones, to the tune of a couple million pounds a week. It's quite useful products to be sold. So let me have you try one. And here you go. What would be the organic product or products for the following reaction? I think, well, I'll give everybody another 15.8 seconds. All right, I think you're all done. So let's do this. And here, what do I have that's different? Carbon, carbon hydroxyl group, alcohol. Ooh, three-membered ring with an oxygen, two carbons. That's ethylene oxide. And when you react an alcohol with ethylene oxide, you get this ether alcohol. What's my R group? Ethyl. So I don't break carbon-carbon single bonds. In this case, the carbon, this end carbon with the hydroxyl group is bonded to the oxygen, then CH2, CH2, OH. And that's what you get. And that's the ether alcohol. Now, I'm going to do something different today. Normally, we take a 5-minute break and do the lab, but today's lab is real quick, so we won't. But before that, and you'll be out in about 10 minutes or so, maybe less, and then I'll spend 5 minutes or less after that. I'll send out the password for test number 1, and you got until tomorrow. But I think it's time for a Dr. White story that's life is stranger than fiction. The company that did that kind of reaction, that's called an ethoxylation reaction, I worked for. I was hired to help improve their quality control lab and improve their product quality because they were having problems. And one of the tests I was asked to improve was this reaction test that helped measure how much have you made to know when you're done with that reaction. And as somebody had developed it at the corporate headquarters, at this time, the company was owned by the division I was working for by PPG, which is located in Pittsburgh. And the company was, where I was working was in Gurnee, Illinois. And I was trying to make this test work better. And I was having problems with it before I even started. They were having a lot of problems. I made it better, but I couldn't make it good enough to really use. And I went to my boss at Illinois and said, I was told this was developed by someone in a corporate research center. Can you tell me who it is? Because I would like to call them and talk to them about some problems I'm having. So my boss said, yes, but there's something I have to yes. And he said, I said, who's the chemist? And he said, Dr. Dahmer. And without thinking, I said, that's not Jeffrey's father. And my boss said, yes, and don't bring up about his son. For those who don't know, Jeffrey Dahmer killed a bunch of people in, I think it was Milwaukee area. And he was also sick enough that he ate some of them and stored their body parts in a freezer. You can look it up online. And every time I talked to his father, who was a very nice person, on the phone, I never met, in the back of my brain, a little voice was saying, ask him about his son, ask him what went wrong. And I never did, thank goodness. But he was always nice. But talk about weird occurrences, true story. But anyways, let's do the lab so I can get you out early, and you can, if you want, work on test number 1. All right, let's look at today's lab. I picked this in case there are questions where students before had things they wanted to ask me. Today's lab is aromatic compounds. I haven't done it all day, but I guess I've been on a winning streak. Everybody see aromatic compounds on your screen? Thank you. All right. Now, aromatic compounds play an important role in your life, and they're found in many spices that you can go out and buy to use for cooking. And it turns out throughout the 14th through 1700s, wars were fought over control of spices and the land where spices were grown. Huge fortunes were made by the Dutch, Spanish, Portuguese, and others, English, controlling these spices. In fact, if you haven't figured out by now, Columbus wasn't really set out to find America. He was trying to find a shorter route to India to get a cheap way to bring in, to transport spices to Europe. He made a wrong turn and found America. And if you also believe it, the Vikings were here before him, but that's another story. All right. Now, many spices and things that come from plants, extracts they're called, contain an aromatic benzene ring in them. And these molecules are found in spices which are eugenol, isoeugenol, vanilla, benzaldehyde, and trans-cinnamaldehyde are the molecules. In this lab, you'll be using an important, very sensitive analytical device, your nose. But you know how sensitive your nose is, very. And if we were face to face, we'd be in a lab right now. I'd have in front of you a bunch of bottles with spices in them for you to smell. Unfortunately, we're not. But the spices, and if you have any at home, smell them on your own. Cinnamon, cloves, nutmeg, vanillin. You don't have benzaldehyde unless you have almond extract. And if you do, that's really benzaldehyde. Now, in the lab today, what I asked you to do is take a small amount of spice and put it on a piece of paper, weighing paper, and smell it and record your observation. Now, for the cloves, put a couple and do this with your fingers and smell your fingers. Now, for liquid, and we only have one, I would have put it on there. Now, here are the spices and chemicals you would be smelling: cloves, cinnamon, nutmeg. Now, vanillin, like vanillin extract, I don't know if you know, you should know this. I'm a vanilla extract freak. I love it. I love vanilla ice cream. I like vanilla frosting. I like vanilla in water with a little sugar, also known as, when it's carbonated, cream soda. And benzaldehyde, which is really the key chemical in cherries and almonds. And when I smell Dr. Pepper, I can smell I think of benzaldehyde or cherries. And when I smell almonds, marzipan is an example, an almond paste, or amaretto liqueur, which I like, I can smell the almonds, the benzaldehyde. But if I think about it, when I smell benzaldehyde pure, I can also smell the cherries. I can switch either way. It's quite neat. I wish we were face to face where you could smell it. Now, the lab would be, you fill out what you think something smells like. And I think most of you have cinnamon, nutmeg. And if you've ever smelled vanilla extract, put down what you think. Now, I helped you with benzaldehyde. How many of you are familiar with the maraschino cherries that come on top of a sundae? No, those are the ones that are bright red and glow in the dark. No, they don't, but I love those. And Dr. Pepper, almonds, and almond. When I smell benzaldehyde, this is what I think of. Now, for today's lab, again, smell this, and I'm going to talk about smelling in a second. And then here are the questions. And drawing of them is for this table, draw the structures. And I tell you, close the key element in there is eugenol, and cinnamon is called trans-cinnamaaldehyde. Wonder where they got that name from. And for nutmeg, it's isoeugenol. Now, for vanilla extract, if you look up the compound vanillin, that's where you'll find it. And benzaldehyde, go to Google. And don't forget to answer question number 3. Students forget that. I don't know why it's hidden at the bottom of the page and they forget to do that. Now, a couple things. I talked about a while back when we talked about aromatic compounds, eugenol, which is also known as oil of cloves. It's the oil coming from cloves. For some of you who cook Christmas hams, or your mother or father, or whoever does the cooking, you know how you put cloves on the ham to give it an extra nice taste. I like the taste of cloves. Well, oil of cloves has an interesting property. It's an anesthetic of sorts. When you put it on your gum, it causes it to freeze or not feel any sensation. And if you go to a good dentist before they inject you with whatever they inject to deaden the pain when they do their work, unfortunately, in my family, I've inherited from my grandfather through my mother, bad dental problems, what I have over my life have I. And good dentists will put that on your skin, oil of cloves on your gum. So when they inject you, the needle goes in, you feel nothing because it deadens the pain. Now, one other thing before I let you go. One of the best places in Chicagoland, you can get it online. You don't have to go. They're in Evanston, Chicago. I think they have a store in Milwaukee. It's called the Spice House. And I've been buying from them since about the 1990s, at least. And their stuff is the best. I've been in their Evanston store when some of the top chefs in Chicago will be in there. I was introduced by the owners to a couple because one time I was in there, they were having trouble with their balances. And I saw that and said, hey, I can help you out. I'm an organic chemist and I manage QC labs. Let me show you how to fix that problem. And they thanked me. So whenever I was in there, they'd always thank me. And if some chef was there, famous ones, they'd introduce me to him. But what I wanted to show you is this right here. Does everybody see the Madagascar double strength vanilla extract? I've got a big bottle in my house. And can you see the price of that? 4 ounces is $42 plus. 8 ounce bottle, which they're out of stock right now, is $82. I usually buy 8 ounce and it's worth every penny of it. Once you use this stuff, you will never, ever want to use I'll use the proper term, garbage they sell in the supermarkets. And with that, I'm done for today. Don't forget, in a little while, I will be sending out the password for test number 1. I'll be checking every hour or two my email today and tomorrow morning. And if you have a question, ask. Also tonight, I'll have my office hour from 5 to 6:15. If you have any problems while you're taking test number 1, stop by, ask questions. And with that, I'll see you on Monday. Don't forget, hand in the lab that's due today, sometime today. And don't forget to hand the test tomorrow by 10 a.m. as a single PDF file. And on Monday, I will go through the answers of test number 1. And by 1 p.m. Sunday, probably, I hope Saturday, if not earlier, I will have, maybe even tomorrow, I have some stuff planned, but maybe I'll have time to do it. I will have your scores posted in D2L. I'll send out an announcement to that effect. And on Monday, we'll go through the alcohol problem set. That's a lot to say. With that, gang gesund, goodbye. Good luck on test number 1. Hopefully you won't need any luck to do well on it. And with that, gang gesund, goodbye.